Hey kids, it's Dr. Owens here, plugging along with Chapter 5. This is Section 4. This is an extension of the lesson that we did previously on scatter plots, and we are going to practice fitting a line, which is called the line of fit, ironically, to a particular set of data that's given to us. The beginning of this lesson was started with an activity that, for the sake of time, we are going to skip over. Just to get to the basics. Remember, with all my lessons, I do try to give you a great lesson, but they are not perfect. Different teachers would probably teach differently, and we definitely teach differently in class. But this is just the highlights to make sure that kids have some support from home. So let's talk about this line of fit. Line of fit. Okay. This is an approximation. It's subjective. So my line of fit will probably be different than yours, which would be different than another student's. Now they should be related, they should be similar, but there may be some variation between us. Okay. This is also used to find an, again, proximate equation that we can use to predict information for the future. This is not connecting the first and last points. Not. This is the most common error that students make. So when points make roughly a line, then it's said that they have a linear relationship. Linear, it has the word line in it, right? Linear. Okay. So for some reason I always imagine these to be bugs. If all the bugs look like they're flying in the same direction, yeah, we could say that they roughly have a linear relationship. Here they seem to be falling the same, so they would be a negative linear relationship. Now this is not just no correlation because they're all over the place, but we say it has a relative no correlation, because it could be that we're zoomed way in on this data, and if we zoomed out, it could be that it does have a linear relationship. You just can't tell it based on the view. So in this case, it looks like there's relatively no correlation, but we don't know for sure because we maybe can't see the whole picture. All right, so the way that we find a line of fit is we plot the data, like here. Draw our line of fit, so however you see fit to draw your line of fit. Choose 2 points that are on or very close to the line. I try to pick things that are far away from each other. I feel like that's more accurate. Calculate the slope and the intercept, write an equation, and then make sure that it matches the data. So to help you with that, I thought that I would walk through a homework question with you. So this is your homework. So I don't often use your homework as part of the notes, but this is just one of those that lends itself a little bit to that. Okay, so I'm going to go in the back. Because I don't want to rob you of some opportunities for practice. So let's look at, say, number 4. Now, first of all, does it look like this has a linear relationship? Yeah, it does. And so it looks like all these things are going the same direction. So I'm going to do the second step. We didn't have to plot this data. It's already given to us. In these, you'll have to plot the data on a coordinate plane. You can draw a line of fit. So I think here represents the data pretty well. Yours might be a tiny bit off, so maybe you did yours a little bit slightly above, slightly below, but that's where mine is. Okay, so step 3 is to choose 2 points that are either on or very close to the line. So what I mean by that is, see this one? That's like right on the grid lines, right? And let's do one that's far away. This is very close to a grid line 2. This one's actually really close too. I could probably use any of those, right? Okay, but I like the ones that are farther away from each other. And so, step 4 is to calculate the slope. You can either do y2 minus y1 over x2 minus x1, or you can just simply count. So rise 2, right 1, or 1, 2, 3, 4, 5, 6. 1, 2, 3, 6 over 3 is 2, which makes sense because both of those would work. So my slope is 2, so it'll be y equals 2x. And then we find the intercept. Now you could, if you wanted to, do this algebraically, but if I have a graph, I think it's just more logical to use the graph. So the intercept is at positive 2. Now if you did this entirely, if you do this mathematically, then you would want to make sure that your graph matches the data. But we use the graph to write the equation, so I think we're good. Okay, so you will do the same for 4, 5, and 6. These already have a linear relationship that we know. The top 3 you have to say yes or no if these suggest a linear relationship. And then for your coordinate planes, if you use the coordinate plane from my classroom, you will have to estimate, because our coordinate planes only go to a 10 by 10, so you might want to make every box worth 2. Or you can just go a little bit off the coordinate plane. I suppose that'd be fine for this one. And for the decimals, you'll need to estimate as well. And then this time, I'm going to ask you to do the word problem. Typically, I like to do those with you in class, but this is one that I think you can handle. So I would like for you to, again, sketch a scatter plot, graph that out, draw a line of fit, and write an equation. So that's all. It's a really quick lesson. If I've lost you, if you need help, you guys know that you can always come see me before school, but that's not helpful if it's like Sunday afternoon. Shoot me an email. Happy to help. And hopefully I can get you fixed up before class. All right, thanks guys for watching, and I'll see you later.